Welcome to this e-content. The topic for this e-content is Introduction to VLSI Design Flow. So what is VLSI? VLSI means Very Large Scale Integration. So millions of transistors are being fabricated in a single chip. What is the use? This is used to create many chips and circuits on a single mini chip of silicon. So for any design, we need a requirement study. So what is the specification? We should know how to implement it, how to validate it, and then we have to market the product. VLSI design cycle. VLSI design cycle starts with a formal formulation of a VLSI chip, follows a series of steps, and eventually produces a packaged chip. Here shows the simplified VLSI design flow. So there are 4 levels of representation. One is behavioral representation, another one is logical or gate level representation, and the next one is circuit level representation, and another one is layout level of representation. So also we can implement this VLSI design in 2 ways. One is from front end and another one is through back end. So front end is of synthesis phase and back end is of layout phase. So 4 levels of representation. So one is behavioral representation, so which gives the functional blocks or finite state machine and the behavior of the circuit. And the second one is logical or gate level representation, which is represented by basic logic gates. The next one is circuit or transistor level representation, which shows the schematic of transistor. And the next one is layout representation, which shows the physical characteristics of a transistor. Let me give you a small explanation about the VLSI design flow. First, we have to get the system specification, then we should know about the architectural design. So for each architecture, the functional verification has to be done. Next, the architecture will be of a group of logic gates, then it has to be designed with the help of logic gates, and then logical verification has to be done. The logic gates is made up of transistors, so circuit design and then circuit verification has to be done. The transistors are drawn with the help of layouts, then layout verification has to be done. So 2 methodology, one is top down design methodology and another one is bottom up design methodology. So top down design methodology defines the top level block and identifies sub blocks. So bottom up methodology starts from this leaf cell to the top level. So this is the Y chart. This is said to be Gaussi's Y chart, which represents the total implementation of VLSI circuits. One is we can enter into structural domain, or we can enter into behavioral domain, or we can enter into geometrical domain. Whatever may be, the final output is the chip implementation. So functional design. The main functional units or interconnect requirements of the system are identified, are area, power, and other parameters. The key idea is to specify the behavior in terms of input, output, timing of each circuits. Logical design, the outcome is called register transfer level. RTL is expressed as a HTL, hardware description language. We can use Verilog or VHDL for programming. So circuit design, this is from the Boolean expression. With the help of logic gates, we used to implement the circuits. And physical design, we convert this logic into a layout. So overall design process. So a designer will be there, some task has to be given, and there are some tools. So we can use architect, logic designer. If you want to design a logic, then you have to go with RTL simulator. If you want to design with the help of circuits, then you should have cell libraries, cell circuit schematics, circuit simulation, and mega cell blocks, and then you can implement using schematic editor. Physical designer, if it is a layout or floor plan, then or if you place on route, then evaluation tools has to be done. Thank you.